Sailing is the passion of millions around the globe. But when it comes to harnessing the wind, there's often a choice to be made. Size versus speed. The two seldom go hand in hand. But now, a brand new boat is rewriting the rulebook. Black Pearl, the world's largest sailing yacht.
Welcome to the Black Pearl, 106 metres, 7.2 metres of draft, 14.5 metres of beam, sails at 22 knots. We expect it to do 30 knots. Without a doubt, that is unique.
Never before has a yacht of this scale been built to sail so fast.
Good morning, welcome on board the sailing yacht Black Pearl.
Today, this $200 million feat of engineering is setting out on crucial sea trials in Tarragona, Spain. Captain Chris Gartner heads up its crew.
The Black Pearl is completely different from almost every other sailing ship ever built. She's just designed to sail.
Drop the ground lines.
It is really a modern day miracle.
The world's largest sailing yacht, Black Pearl is the length of 10 London buses. Its tri-deck design is equipped with a helideck, state-of-the-art tender garage, and can accommodate 38 guests and crew. All powered through the sea by an innovative 3-masted rig, equipped with nearly 3,000 square meters of sail.
It is a sailing machine. It is so on the cutting edge. Yeah, it's exciting.
However, creating such a vast vessel poses many impossible engineering challenges.
Looking good.
How do you ensure the largest hull of its kind will glide through the water?
Moving close.
221.
And stand up to the unpredictable ocean?
Every time we leave the dock, it feels great.
But perhaps the biggest problem is making this 100-meter-long, near 3,000-ton superyacht a world-class racer.
And we're only 10 degrees starboard, and it turns that quick. We want to sail fast. Sure, there's a lot of boats out there that are real flyers, but they're a quarter of the size.
To get up to speed, this marine giant requires a staggering 2,900 square meters of sail area. But how do you rig and control such a vast amount of canvas? Could a marvel from the past help with this seemingly impossible problem?
Well, this is not how I usually start my days.
Naval architect Nick Bradbeer is in Greenwich, London, scaling a supersized 150-year-old speed machine.
I am climbing up a tall ship's rigging, and I've never done this before. I'm a little bit nervous, as well as excited.
That, incredibly, could provide an answer for Black Pearl's design challenge. Equipped with 47-meter-high masts, this 85-meter-long maritime masterpiece was once one of the fastest ships on the planet.
This is the Cutty Sark, one of the last surviving clipper ships. And back in 1869, when she was built, she was an astonishing piece of engineering.
This amazing vessel was the result of a nation's quest for a decent cup of tea. A thirst that started 200 years before it was built.
Tea was imported from China, from India, and it was all imported by the East India Company. They were the only people allowed to bring tea into England.
With no competition, their ships, known as East Indiamen, weren't built for speed. 1,200 tons of tea was crammed on board.
Please.
A typical round trip to the Far East took a leisurely 2 years. But in 1834, the East India Company's tea monopoly was ended. Other ships would now be vying for the tea market's rich pickings. Their slow, bulky boats now had a major problem.
Wealthy Londoners were willing to pay a premium for that first batch of tea back from every harvest. So an enterprising group of merchants and sailors realised that they could make a lot of money, and that meant they would need a new kind of ship, something that was much faster than anything that had gone before.
Scottish shipping entrepreneur John Jock Willis and engineer Hercules Linton came up with a trailblazing solution. The Cutty Sark was a legendary British tea clipper, so named because of her ability to clip off the miles at breakneck speed.
The Cutty Sark was a very fast ship. She did speeds up to 17 knots, which is about twice as fast as the ships that came before her, and actually is about the same speed as a lot of merchant ships do today.
Her secret? A towering square-rigged three-mast design. A sailing powerhouse that could inspire the Black Pearl's team.
One of the things that really sets a clipper apart, because she has to go fast, is the sheer quantity of sail that she's designed to carry. Looking up, we've got 11 miles of rigging, 32 sails, nearly 3,000 square metres of canvas, which is just an unbelievable amount. I can't even quite fit them all in my field of vision. She's just a machine for carrying as much canvas as possible, because it's all about speed. The more sail she carries, the faster she can go.
The Cutty Sark and this new class of ship slashed 20 weeks off a round trip to China. Its awesome rig making the most of whatever wind was available.
If you're in light winds, you want to cram on as much sail as you can. If you're in a heavy wind, then there's only so much sail you dare pack on. But the clipper captains were driven by speed, so even in high winds, they keep packing it on to keep that speed up.
The Cutty Sark spent the 1870s speeding tea across the world's oceans. By the 1880s, she was working the Australian wool trade routes, holding her own against a new breed of ship.
Even in the age of steam, she was still far outstripping the speed of those steamships over that long run. She's a piece of history, and she's an incredible piece of engineering.
Like the Cutty Sark, the Black Pearl is built for speed. In 2016, its super sleek hull is delivered. But this engineering marvel only comes to life when its epic rig is installed.
Keep going, 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 keep going. That's it, we're down. Get the boxing.
Inspired by the historic clipper, a trio of masts resemble the Cutty Sark's iconic design, but their 66-metre height would tower above it. Engineering on this scale produces something special. The world's largest sailing yacht. Chris Gartner captains this extraordinary vessel that's shaped by the past.
Based on all the principles of the clipper ship, we've incorporated everything that worked for them using modern day technology and materials, and now we've built a flyer.
Black Pearl's standout engineering is its game-changing square-rigged mast system.
This is the dyno rig of the Black Pearl. It's a carbon fiber structure that stands about 66 meters from the water up to the masthead. There's so much engineering in this whole structure, it's mind-blowing.
Each of the three masts is flanked by a series of rib-like structures known as yard arms. These subdivide the rig into 15 low-loaded sections, allowing the engineers to unfurl 2,900 square meters of sail. Today, a sail test is about to get underway. First, a manual inspection must be carried out on one of Black Pearl's massive masts.
Going up there, I leave that for the young guys. In case they fall, we're not really losing as much as if I were to fall off the rig.
The vertigo-inducing job falls to rigmaster Declan Clamp.
It's basically getting hoisted up by a winch.
And stop.
He's on truss number 6, and he will begin his inspection from up there.
View's great. Always a good view from 60 meters up.
We take a lot of safeguards in order to prevent any mishaps.
Everything's okay up here. Cool. And you get a real scale for the boat up here. You realise how big it all is.
Now the checks are complete, Chris can automatically bring this engineering marvel to life.
And I'm going to set the sail. Right now, the 4 outhaul winches are pulling on the 4 corners of the sail and dragging the sail out. It's fast to set. Days of old, the poor sailors on those boats would be working their you-know-what's off, climbing up the rigs, pulling them up towards themselves while they're balanced on little tiny foot ropes, and to do all of their sails probably take them hours.
Today, Black Pearl's sails can be set in less than 7 minutes. But even that's not the most impressive quality of this rig. It can also revolve.
We simply rotate the rigs, the entire mast rotates, and that in turn trims or eases for tuning the sails. It just facilitates something that's much easier to do, much safer to do on a big ship.
The innovative engineering that makes this possible is concealed below deck.
Yeah, Declan, can you please rotate the foremast 180?
Yacht manager Derek Munro is putting it through its paces.
So we're now in the foremast technical space, and in here we have the foremast tube that comes down. There are 4 of these mast rotation units which turn the mast around as and when we need it. And in the middle, as the mast rotates, we need to manage the cables so that they don't get tangled up. And that's what all this is up here, the cable management system.
This phenomenal technology rotates 32 tons of carbon fibre mast. Its immense capacity for canvas propels this 3,000-ton super yacht to a jaw-dropping 20 knots.
It's revolutionary as far as ease, safety, and efficiency. When we have a full set of sails up, you can actually see the masts moving. It's like a living animal. You can have a maximum of about 3 to 4 meters flex at the masthead from 0. These rigs are living and breathing. They're just moving all over the place. The Dyna rig is one of the most incredible advances in sailing.
But to engineer a purebred racing yacht, the team face more problems. Lurking below the surface lies a huge challenge.
We want to ensure that everything underneath the hull is as streamlined as possible, because it's all about winning the race.
For Black Pearl, only perfection will do.
If you've got any forms of resistance underneath there, then that will slow you down.
Black Pearl is the largest sailing yacht in the world. A brand new engineering colossus, currently taking marine engineering into uncharted territory. At 106 meters long and weighing in at almost 3,000 tons, this mammoth ship is equipped with 2 diesel engines. But its crowning glory is a trio of 60-meter-high rotating rigs, capable of propelling Black Pearl to over 20 knots. It's captained by Chris Gartner.
The horn on the Black Pearl, as impressive as the rest of the boat. It's mind-boggling, to be a part of such a big boat, so advanced. It is mind-boggling for sure.
Black Pearl's unique supersized design is built to race and break records.
We're planning on being at your pilot station at about 4 or 5.
Today, the team are preparing for its latest sea trial to see if she has what it takes.
Understood.
Chief Engineer Richard Tatlow must ensure her hull is in perfect shape.
When we're racing, we're under sail, and we want to ensure that everything underneath the hull is as streamlined as possible to maximise our speed, because it's all about winning the race. Hi, Alberto. How's it going? Good. So currently the guys are kitting up with their dive equipment, where they're going to go down underneath the hull and they're going to clean our propellers. They're also going to inspect the rest of the hull to make sure we haven't got any growth that can cause us drag.
On a boat of such enormous proportions, this fingertip search takes the best part of a day.
Ooh. It looks like a band, is it? A band?
It's a band.
Yeah. Can you see any gone inside? Basically what we're seeing around the starboard propeller, it looked like a rope. And what we're also looking at is the starboard propeller is heavily fouled, so that needs to be cleaned. It's a good call to get this done.
The clean-up's not an issue. But the propellers themselves create a major problem. Used in light winds and to manoeuvre around harbours, they permanently protrude beneath the hull, compromising Black Pearl's underwater streamlining when under sail.
The propellers are always underneath there. We can't retract the propellers. We can only retract our thrusters and our anchor.
The drag through the water caused by this pair of 1.2-metre-wide propellers could thwart Black Pearl's racing ambitions. Could an innovation from the past offer a solution to this unfathomable problem? The surprising answer for Black Pearl can be found at a British airfield. Engineer Dan Dickrell is discovering an historic masterpiece, currently being brought back to its former glory.
Look at this. This is the C-47, one of the most iconic and legendary aircraft of the Second World War. A plane famous for dropping paratroopers over occupied France in D-Day. It's a really beautiful airplane. It's easy to imagine what it would have been like going across the channel over enemy territory with flak going off. In the event that this airplane would lose an engine, the only way to get back safely is to maximize the ability of the remaining engine to get you to the ground safely.
But in an emergency, the disabled engine's propellers could create a major problem. Sitting in the airflow, they caused drag, which burned precious fuel. The solution was down to American engineer Frank Caldwell. He devised the Hydromatic, a propeller which utilized hydraulics to change the pitch of its blades. Known as feathering, it's a process that could help out Black Pearl.
In the event of losing an engine, the pilot reaches up, pulls the feathering button, which feathers the blades of the propeller. The 3 propeller blades will rotate, taking the fat part of the blade out of the airstream, giving it the knife edge. This reduces drag greatly and effectively helps this plane get home safely.
Today, Dan is putting his faith in Caldwell's brilliant invention, with a daredevil experiment on board a modern twin-engined plane.
So currently we're about 3,500 feet and going about 115 knots. And we're going to simulate an engine failure. When I give Captain Rob the signal, he's going to reach down and cut the power to that engine right there, and we're going to see what happens. I can't believe we're going to do this. All right, let's cut it. So there's some control instability, there's some alarms going off right now. Even though the prop is turning, that engine is actually not generating any power. It's called windmilling, and the broad side of that prop is facing the oncoming air. It's creating a lot of drag. So to maintain this altitude, eventually this airplane will stall and fall out of the sky. This is not a great situation at all to be in. Now, yeah, so we got a stall warning.
Luckily, this plane is equipped with a Caldwell-inspired variable pitch propeller.
All right, the solution to this problem is we're gonna feather the engine, so go ahead and feather, please. All right, so instantly there was an effect on the plane, and while it looks scary, the prop's not turning anymore, we feathered the blades. Now the knife edge is into the wind. The airspeed is slowly increasing, so the good engine doesn't have to do as much work. We're no longer in danger of literally falling out of the sky.
Since its launch, the Hydromatic has transformed air safety. An engineering breakthrough that has helped shape the history of flight. The team at Black Pearl have been inspired by this aeronautical game changer. But their pitched propellers cut through the waves.
Copy that. All lines off.
Captain Chris Gartner is using the props to maneuver the 106-meter super yacht into open water for today's all-important sailing trial.
Copy that. Thank you. Actually, we got a little bit of wind today. Might be good sailing.
Below deck, Chief Engineer Richard Tatlow can monitor Black Pearl's cutting-edge propeller system from its nerve centre, engine control.
As you can see under the water here, our propeller is obviously rotating, providing propulsion for the vessel. Currently we have a pitch of around about 70%. So there's the shaft line and there's the blades, and we have about that much pitch on. And things are looking pretty good.
But as the Black Pearl goes through her extraordinary metamorphosis,
We would like to set sails in 10 minutes. Is everything away?
Yeah, we're all set, Chris. No problems. Just living the dream.
We are beginning to have fun. We are setting sails.
the 1.2-meter wide controlled pitch propellers go through a change of their own to complete this streamlined sailing machine. From a 70% pitched motoring position, the blades are electronically feathered to what's known as zero pitch.
I'll go stop on starboard engine.
Okay. Now you're going to see our propellers start to slow down.
Stop on port engine.
Okay. Stop.
Yeah, very impressive. Thank you very much, Steve.
So now you can see the props are no longer turning. The blades are in a feathered position, in their least resistant position. So now we're sailing and we're dragging them through the water, and they are not slowing us down any.
The water flows so efficiently over the blades, Black Pearl's sailing speed is increased by 2 knots. However, the propeller's ingenious engineering doesn't end there. On this giant boat, which consumes the same electricity as 25 family homes, the propeller's pitch can be altered to generate power when under sail.
We can turn them into a form of a turbine. Because we can control the pitch, we can allow them to rotate, and as they rotate, they're coupled together on the main shaft line into an electric motor. We can then generate electricity. So here we go. As we can see, that was the shaft brake releasing, and then the blades are beginning to come out of this feathering position, starting to open up and act as a turbine. Very shortly, we'll be generating enough electricity to run the ship's load.
But to survive the seas, Black Pearl's engineers must overcome another huge problem, created by its enormous size.
With the hull, all the forces exerted onto the boat itself by the rigs, the sea, there is a lot of twisting and a lot of movement.
If the hull isn't phenomenally strong, there's a danger it could fail.
Not only could it be catastrophic for the boat, but it could be tragic for someone's life.
Tarragona, a Spanish port harbouring a brand new feat of engineering. Black Pearl, the largest sailing yacht on the planet. 106 metres long and 15 metres wide, Black Pearl can accommodate 38 guests and crew and an assortment of advanced equipment, all propelled by 3,000 square metres of sail. Its unique square rig, electronically controlled from 3 different sailing stations. The main hub is the ship's bridge, where Captain Chris Gartner has mind-blowing technology at his disposal.
I think the sailing station is really what makes this boat special. Nothing in the world has this. In order to sail the boat, it requires one person. We can control all masts and turn the rigs all at once, or just an individual one. This page here is how we control which sails we would like to set at that particular moment. So you just simply select it, and we'll be able to deploy all the sail area in less than 7 minutes.
This automated rig is one of a kind, but its mammoth proportions create a big problem for its engineers. The huge masts and Black Pearl's sheer scale place the body of the ship under immense pressure.
As far as the Black Pearl with the hull, with its length overall, all the forces exerted onto the boat itself by the rigs, the sea, there is a lot of twisting and a lot of movement.
The engineers need a lightweight material to competitively race. But for a boat this size, if it's not exceptionally strong, the entire hull could fail.
If it does go wrong, not only could it be catastrophic for the boat, but it could be tragic for someone's life.
Can the pioneers of the past help out with this seemingly impossible problem? The solution for the Black Pearl lies in Philadelphia. Local historian Max Kaiserman is discovering a maritime game-changer born from necessity in the aftermath of the American Civil War.
The Civil War had destroyed most of what was left of the old sailing Navy, and they really hadn't rebuilt yet. The ships that were still left in the US Navy in early 1880s were wooden ships. Some of them were ironclads or iron ships, very low to the water, just for use in rivers and protecting the coast.
But the dilapidated US Navy had a major problem. It now faced a new threat in the oceans, from seafaring nations such as Britain and France.
So by the middle of the 1880s, the US Navy really needed to step up to a more modern material.
It was Secretary of the Navy William Chandler who came up with the solution: a new breed of ship constructed with a revolutionary material.
So what we're standing next to is the USS Olympia. She's the oldest steel warship left in the world. The shift from wood to iron to steel was monumental. Iron was brittle, wood was incredibly costly and weak compared to steel.
Made by chemically modifying iron, steel is incredibly strong and light. Much of Olympia's hull is under an inch thick. The perfect lightweight solution for her high-speed seaborne operations.
The Olympia represents actually an entirely new type of Navy, and a hull that was able to withstand hurricanes, high seas, and armor-piercing shells from other ships.
In the depths of the hull, the malleable quality of steel comes into its own.
Oh wow, you can actually, it's cold because on the other side is the water. We're about 15 feet below the waterline here. This is steel. It's a mild nickel steel, about 3/4 inch thick. The steel here is curved into place. It can be welded. You can see where the plates are riveted together. None of that's possible with wood. It's almost impossible with iron.
Her sleek lines and super lightweight steel hull enabled Olympia to steam at 10 knots for 24,000 kilometers without refueling. And in the heat of battle, this new material offered unprecedented protection.
Where we are now is actually one of the few places that's armored. Around the 5-inch guns is about 5 inches thick. This steel armor could protect beyond anything wood or iron could do. If I were a sailor on a ship in the 1890s, I'd much prefer to be on a ship behind 5 inches or 8 inches of steel armor rather than a foot of wood that could splinter and kill me, just the wood.
By 1898, the trailblazing steel ships had transformed the US Navy from obscurity into a global military power.
We float still today because of those engineers over 120 years ago decided to use steel on new warships. I think Olympia is a marvel of engineering.
Steel has enabled Black Pearl's engineers to build the largest sailing yacht in the world. With 21st century technology at their disposal, this cutting-edge giant is longer than the USS Olympia, but at 3,000 tons, it's virtually half the historic ship's weight. Despite this, it's still remarkably strong.
As far as the material used in the Black Pearl, steel is definitely the best choice. You know, there's the safety factors, the strength factors, and it certainly resists so much, you know, from corrosion. It's not so affected by the elements of the salt water. And if you hit something in the sea, which is always a consideration to dealing with the twisting, the bending, and the forces that will exert on the boat from the masts in big seas.
The 720-ton hull carries over 1,300 tons of outfitting weight and 300 tons of ballast. Its unique shape took 14 months to construct in a Rotterdam shipyard in the Netherlands. The flexible quality of steel, as thin as 8 millimeters, allowed engineers to form a streamlined hull built for speed. A lightweight aluminium superstructure saves vital weight, delivering the impossible. A 106-meter-long super yacht designed to break records. But perhaps the standout engineering is Black Pearl's one-of-a-kind bow.
The special thing about this is, as you can see, it doesn't look like any other bow you'll see on any other motorboat or sailing boat. The shape of the bow at the lower end makes her very efficient through the waves. Instead of riding through them, she tends to ride over them, but it's fine enough at the same time that she'll slice through whatever you get. But it just means she's much faster. And it's very effective too, because when we get 1-2 meter seas, we have a very dry foredeck. And it's because it's hitting this bow and dispersing off the boat instead of coming right up on top and making it wet. I think when everyone sees how efficient this bow is, they'd be a bit silly if someone didn't copy it.
Black Pearl's design is so advanced. Its team are targeting the 30-knot barrier, a first for a sailing yacht of this size.
It excites me a lot to be a part of this, to try to break these records. It's just an amazing, amazing, amazing sailboat.
But a new, ambitious transatlantic goal throws up more challenges for the world's largest sailing yacht.
To cross the Atlantic with zero fossil fuels means that we need to manage the power on the boat very carefully.
For a boat which consumes 8,000 kilowatts of electricity a month, a totally self-sufficient voyage from Europe to America sounds impossible.
Christopher Columbus did it, but as far as I'm aware, he had no fridge freezer, no laundry, no air conditioning.
Can Black Pearl follow in the footsteps of one of history's greats? Black Pearl is changing the face of marine design. Currently undergoing racing trials, the world's largest sailing yacht is built for speed and has the 30-knot barrier in its sights.
Yeah, it's freshening nicely, huh? Very good. Great day of sailing so far. I feel like it's getting proven. It's already great, but we're proving the systems that were put onto the boat, so it's getting better and better.
But to make its mark, this audacious yacht must also have staying power at sea. Millions of dollars have been pumped into innovative technology developed to make Black Pearl self-sufficient.
So as you can imagine, on Black Pearl, water consumption can be quite high. So what we do is we try and minimize that as much as possible. So this is actually raw sewage that's being compressed through a membrane system, then a series of fine filters through a treatment plant. That water is just used for basically washing down the boat, but apparently I have been told by the manufacturers that you can drink it. And no, I haven't been brave enough to try.
Black Pearl's sustainable systems and regenerating propellers are cutting edge. But even these aren't enough to cope with the owner's latest audacious goal: a fossil fuel-free transatlantic crossing.
To cross the Atlantic with zero fossil fuels means that we need to manage the power on the boat very carefully. Christopher Columbus did it, but as far as I'm aware, he had no fridge freezer, no laundry, no air conditioning. The jacuzzi didn't work on his boat as well. Whereas on here, we have all the comforts of home and we want to try and keep them going.
On a mega yacht with the same energy demands as a small residential street, completing a 12-day zero-carbon crossing seems an impossible challenge. But an out-of-this-world historic innovation could offer a sustainable solution for the world's biggest sailing yacht. Physicist Susie Shee is visiting Brittany in France, discovering how the answer for Black Pearl originated in the stars.
At the moment, there's about 2,000 satellites orbiting the Earth, and they're doing everything from TV to data communications. But of course, they weren't always up there. This radome is at the Plumeau-Bordeaux Telecom Centre, and this has an incredible history in the development of satellite telecommunications. It's absolutely incredible, and it's enormous.
During the 1950s, a new era of space exploration unfolded. And with it came the potential to transform global communications. Early satellite experiments successfully relayed signals to and from space. It wasn't long before the global stage was beckoning.
Engineers in the US came up with an ambitious new project. They wanted to send live TV images from the US to Europe and beyond. So this is what they came up with. This is Telstar, which is a global communications satellite. It can take live images from the US up into space and back down to Europe, transmitting them across the Earth.
But achieving this meant overcoming a massive problem. Like Black Pearl sailing across the vast oceans, to be viable, Telstar had to be totally self-sufficient in the isolated vacuum of space.
Early satellites were powered by batteries, and in orbit they'd only last a week or sometimes days before the battery would go flat. So to keep the satellites up there for longer, scientists had to come up with a new solution.
In 1954, Bell Lab engineers Calvin Fuller, Gerald Pearson and Darrell Chapin were developing silicon transistors when they made an unexpected discovery. One of their transistors began producing electricity when exposed to light. Silicon had the potential to produce the first practical form of solar power. A special quality only seen at an atomic level.
Now, what I've got set up here is two different layers of silicon, like in a solar cell. And the important thing is that each layer has a slightly different atomic structure. So these are my atoms, and around the atoms are electrons. On this side, there's actually slightly more electrons So this side is overall more negative, so we call it N-type silicon. And the other side, there's actually a slight lack of electrons, so I'm going to take some away. So this one is overall positive and P-type silicon.
A section between the silicon layers acts as a junction, allowing electrons to migrate, creating an electric field, a process stimulated by light.
The sun shines down on the top of the solar cell, and all that light energy can liberate electrons from their atoms in the center here. So now these free electrons are moved upwards by the electric field, and if we connect with a terminal on the top and the bottom, that creates a path for these electrons to travel round and fill the holes on the other side. And it's the flow of those electrons that provides an electric current which allows us to do work, such as powering a calculator. And you can see there's actually a couple of little solar cells just on the top of the calculator here.
The infinite power of the silicon solar cell was the perfect solution for space. In 1962, the Telstar satellite was launched, equipped with this game-changing innovation.
They actually coated Telstar with 3,600 solar cells mounted on platinum and coated with sapphire to protect them from the high levels of radiation in space. And that allowed it to produce about 14 watts of power, enough for it to relay about 600 telephone calls and a live TV feed.
To complete an historic live transatlantic satellite broadcast, Telstar received signals from the United States, magnified them by 10 billion before beaming them here to France's mammoth telecom centre.
This antenna is the first place that received the signal from Telstar. They actually transmitted a TV broadcast featuring President Kennedy.
I understand that part of today's press conference is being relayed by the Telstar communications satellite, viewers across the Atlantic, and this is another indication of the extraordinary world in which we live.
The success of Telstar helped demonstrate how good solar technology was, not just up in space, but also down here on Earth.
From the vacuum of space to the vast seas, Black Pearl's engineers have been inspired to develop their own solar technology. Their ambitious goal: to sail the world's largest yacht across the Atlantic without burning any fossil fuel.
One of the solutions we've been looking at for the last few years is to put solar cells on the sails. Firstly, we need to consider the weight, we need to consider the flexibility, and we need to consider the cable connections. So that takes us to technology which is called SIGS, which is about the thickness of a piece of paper.
At just 0.5 millimeter thick, the engineers plan to bond this super lightweight cutting-edge system to Black Pearl's Dacron sails without compromising their performance.
The solar cells, and it's very, very flexible. We can easily get the rotation on the sail. We'll probably end up, if we're lucky, at 50% of that with solar cells.
That's about 1,400 square meters of solar technology, mounted on Black Pearl's 15 sails. Set to deliver around 22% efficiency through a network of cabling to the ship's 384 batteries.
We should get enough power to run the vessel with all the crew on board and all systems running, which means we should get around about 160 to 170 kilowatt hours. It's enough to provide us with enough power to run the boat without the requirement for fossil fuels. When it happens, it will be an amazing piece of engineering, and it'll be phenomenal to see it, and it's just one more step that we're taking in the future to making the boat a little bit greener.
By pushing the engineering envelope, this team are opening up the world's oceans to the remarkable Black Pearl.
Nobody, to my knowledge, has attempted to do anything like this before. No, this is one of a kind.
Black Pearl is, without a doubt, the most unique and best sailing vessel of her type. Every day we go out on sea trials or sailing, it still, gets my heart going.
By building on the work of the inspirational pioneers of the past, adapting and making discoveries of their own, the engineers are succeeding in making the impossible possible.
To be part of a project that is so groundbreaking like the Black Pearl is super exciting. And I can't wait to continue on and make this one of the most famous boats ever to sail the seas.